I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
Oh, there was a space race.
Roman Titov of Russia returns to Earth.
We knew what the Soviets were doing. They launched Sputnik before we put a satellite in orbit. There was a panic mode.
The biggest challenge was to escape gravity, and that, as we understood, took the biggest engine ever.
You got 3 guys riding this thing, and you got to make sure it's going to work.
30 seconds and counting.
There are people sleeping on the hoods of cars, in the trunks of cars, on the ground, everywhere. It's just people everywhere.
T-minus 15 seconds.
We knew it was history. We knew it was history in the making.
5, 4, 3, 2, 1. Liftoff. We have a liftoff. 32 minutes past the hour.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
As World War II ended,
First, you duck.
and the Cold War
Then
heated up,
you cover.
so did the race to space.
The potential to send Americans to the moon attracted thousands of young engineers from around the country, including from the University of Tennessee.
Well, I was born and raised in Tennessee, and I went to Knoxville, educated there at the University of Tennessee, got my engineering degree, and then came to Huntsville. Signed on as a test engineer under the von Braun arrangement.
German scientist Werner von Braun was one of the world's leading rocket scientists and a pioneer in the American race to the moon.
But Braun had a real talent for working with people and understanding things like that.
His team of German scientists led the efforts at NASA's Marshall Space Flight Center in Huntsville, Alabama, nearly 200 miles southwest of Knoxville. It's here they built the Saturn V rocket, the vehicle that would propel astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins to the moon.
The Saturn V is going to be a technological marvel.
It had the most power, and it was the most complex in so many ways. The biggest challenge was to escape gravity. And that, as we understood, took the biggest engine ever.
While engineers in Huntsville tested every aspect of the rocket on the ground, 49 miles away in Tullahoma, Tennessee, scientists tried to figure out what would happen in the vacuum of space.
Well, we're inside the J4 Large Rocket Development Test Facility here at AEDC. We simulate how a rocket propulsion system will perform in a higher atmosphere and also in outer space.
Today, the J4 test cell at Arnold Engineering Development Complex is quiet. But 50 years ago, it hummed with round-the-clock testing of the entire Apollo system.
Testing was very new. I mean, AEDC was basically a teenager, and so we were still learning how to test. A lot of the people who were doing the testing were kind of like myself. They were very young, and so everybody was learning at the same time.
Dr. Bill Baker is the base's test operations technical director, but when he showed up in 1964, he was just a junior engineer.
I was so afraid that the space program was going to be over, but before I got out of school, I went to school year-round. Well, the very first test that I worked on when I was here was basically measuring the dynamic stability of the escape module.
They said that if the rocket were to malfunction, it would be to have the energy equivalency of a small atomic bomb. So you got 3 guys riding this thing, and you got to make sure it's going to work. So an extensive amount of testing had to be done to validate that the engines would operate.
But the end of the decade was quickly approaching. NASA pushed for what's called an all-up approach to speed up the process.
What NASA says is we don't have time for that. What we need to do is we need to test everything at one time. And Apollo 4 in November of 1967 was that test. The entire Saturn V launch vehicle that had never been launched before, and it was flawless. So it really showed them that they were on the right track.
All of a sudden, it just lights a fire under you, literally.
The Apollo 4 mission was unmanned, and so was Apollo 6, but it was riddled with issues.
There were all types of problems. You had pogo in the first stage, which is a vibration basically through the entire vehicle. 2 engines on the second stage had to shut down. And the next launch of the Saturn V would send human beings to the moon. Now that took a lot of bravery.
The crew of Apollo 8 has a message that we would like to send to you.
On Christmas Eve 1968, Apollo 8 sent men around the moon for the first time.
God created the heaven and the earth.
It was hailed as a pivotal win for a space program facing budget woes and public scrutiny.
And God bless all of you on the good earth.
It proved the U.S. was capable of what was considered science fiction a few years earlier.
We were confident of the launch vehicles, we were confident of all the things, but then the one unknown was we were going to land a man on the moon, and that had never been done. So that's where that's where the pucker string gets a little tight.
On the morning of July 16, 1969, thousands of cars lined the roads and beaches near Kennedy Space Center in Florida, hoping to catch a glimpse of history.
There are people sleeping on the hoods of cars, in the trunks of cars, on the ground, everywhere. It's just people everywhere.
At the time, Don Ferguson worked for the Knoxville News Sentinel. He and his family traveled the 704 miles to Cape Canaveral to see the launch in person.
You had to watch out, people sleeping on the ground, in the chaise lounges around the pool, everywhere, just people everywhere. So we commandeered chairs and went to the balcony and had us a good perch from which to view the blast-off.
There's Johnson standing up.
Wilson Horde, another man from East Tennessee who represented Union Carbide in Oak Ridge, was among the thousands in Florida for the launch. But he got a seat in the coveted VIP bleachers alongside celebrities and politicians.
I was busy with a small camera that just made individual shots. I was clicking that camera as fast as it would take them.
5, 4, 3.
And when you get in that countdown mode,
1.
You celebrate once they get to orbit.
Liftoff. We have a liftoff. 32 minutes past the hour.
It was a loud cheer when it went off.
Shortly thereafter, just seconds, and we felt the balcony shake.
I won't forget, even at my age now. 92.
Oh, you watch everything and you know that here's the culmination of everything you've worked on. You see it happen, and that was a fabulous moment.
I've covered several things. I've had several good interviews over the years. This was by far the most historic thing that I've ever been involved in.
Houston, Apollo 11 insiders gave us a magnificent ride.
With 200,000 miles ahead of them, the 3 astronauts were on their way to the moon. When they got there, they'd need a tool designed by a man in Lenore City.
Eagle looking great, your go.
Neil Armstrong is the pilot there. He's got to land this thing.
Listen, Dave, everything's going just swimmingly.
They'd picked out a landing spot, and they thought they understood it pretty well.
At the Earth, right out our front window.
But pretty quickly, Neil understands that there's stuff down here. There's boulders the size of cars, there's craters the size of football fields.
And Eagle Houston, we got data dropouts.
There's a lot of alarm bells going off.
Affirmative, program alarm.
The lunar module itself was having computer problems.
Give us a reading on the 1202 program alarm.
The reason for those computer problems was it was working too hard.
Roger, we got you. We're going at alarm.
The astronauts had heard these things before. They understood what was happening.
1201 alarm. Set time for go flight.
And finally, ignoring all of the warnings and moving himself into a right place.
Capcom, we're go for landing. Altitude 4200. Houston, you're go for landing, over.
Neil is able to put that vehicle down.
Tranquility Base here. The Eagle has landed.
The first tool astronauts would need when they stepped out of the lunar module
These are the original blueprints. You can see the different sections on this one.
Came from these aging blueprints, discolored with coffee stains, more than 50 years old.
My name's Michael Ellis. My dad was Glenn Ellis, and as an employee draftsman at Union Carbide at Oak Ridge National Laboratory in the 60s, in the late 60s, he designed and drew the plans for the moon, what I call the moon scoop.
Officially known as the contingency soil sampler, the moon scoop was the first tool astronaut Neil Armstrong needed once he stepped on the moon.
That's one small step for man, one giant leap for mankind.
Everything that the astronauts had, at least when they first exited the module to step foot on the moon, had to be on their uniform. They couldn't carry anything. So we talked about the fact that it needed to be a shovel that could be folded up and put in a pocket.
Like powdered charcoal.
They stuck it out and got some soil samples just in case things went south and they had to leave the moon. They had at least put some soil.
And it's just neat now to think back that Daddy was doing that. You know, you don't realize until you're grown.
22 years after his death, the Ellis family looks to his blueprints for a glimpse at his role in history. Photos of the moon landing hang in the foyer of his grandson's house, a thank you from NASA to the Lenoir City draftsmen. But their favorite story of the tool their grandfather designed is one that never should have happened.
You might recognize what I have in my hand as the handle for the contingency sample.
Nearly 2 years after Armstrong first stepped foot on the moon, astronaut Alan Shepard was doing the same for Apollo 14. But he had a surprise no one saw coming.
Yes, but I'm going to try an old sand trap shot here.
Shepard used the contingency sampler to rig up the galaxy's longest golf shot.
And he had some help from other engineers and technicians so he wouldn't get detected. And when he got to the moon, he was able to attach the head of that 6-iron, drop 2 golf balls on the surface, and hit both of them where he famously says, miles and miles and miles.
Miles and miles and miles.
The contingency sampler was used on most every mission to the moon. Luckily, it never had to be the sole source of samples, so NASA had another challenge. They needed something that would store and protect additional moon rocks, and they looked to Y-12 in Oak Ridge.
Well, the people here in Oak Ridge that actually worked on the box knew the importance of what they were doing, and they were proud to be a part of a race to the moon.
By the time Apollo 11 approached in the late 60s, Y-12 already had a growing relationship with NASA.
During the Gemini project, there was Project Big, the blood in Gemini, where Y-12 came up with some sample containers to take blood samples into space to find out if being in a space environment would change the DNA of our blood.
It made sense for NASA to approach Y-12 when looking for someone to design something that could safely store lunar samples. They dubbed it the moon box.
The moon box was made out of a solid piece of aluminum. There were no seams, there were no welds, which would make it more leak tight. There were 4 straps attached to the container to make sure that it didn't open, and it also had to be designed so that an astronaut could open and close it in a spacesuit with gloves, so it had to be pretty easy to open and close.
At the American Museum of Science and Energy, there's one on display, only this moon box never made it to the moon. Throughout the entire Apollo program, more than 16 did.
There were a large number of people who did work on it. There was one who, when he passed away, his one request was that the moon box be at his funeral, because it was the thing that he was most proud of.
As the Apollo program continued past the first moon landing, geologists grew frustrated that the samples in the moon boxes weren't clearly identified. So an engineer at Y-12 had an idea.
They needed the small bags to isolate those different rocks, and they needed them made out of Teflon, but they also needed them to be certain size and made in a certain way. So Y-12 went to the knitting nook here in Oak Ridge, and Lorraine Shook is the lady that actually did the knitting to make the Teflon bag.
There's a shopping mall where the knitting nook once stood. And Lorraine Shook has since passed away. But her seemingly small contribution made it easier for geologists to study the moon's surface for decades to come.
The Apollo program is the gift that keeps on giving. These 842 pounds of rocks are still being studied by new technologies, new analytical technologies, and we keep learning new things that we didn't know before.
Hap McSween is a retired planetary science professor at the University of Tennessee. He studied rocks from several of the Apollo missions.
The moon is geologically dead, so it gives us a picture of what happened in the early solar system that we can't get by studying from our own planet.
The more than 800 pounds of lunar samples would continue to amaze scientists for the next half a century. And as NASA looks to return to the moon and beyond in the next few years, they're once again looking to East Tennesseans to help with the journey.
Apollo started it all. The Apollo program returned to Earth 842 pounds of rocks and soil samples. And that really revolutionized how we saw planetary exploration.
At the University of Tennessee, scientists are still using samples from the 842 pounds to learn new things about the moon and the Earth.
We've cut and ground the rock down.
Professor Molly McCanta is the latest UT researcher to study the rocks.
Let me just focus in on some of these.
Later this year, she and a team of scientists from across the country will open moon samples from Apollo 17.
It was sealed, the astronauts brought it back, and it hasn't been opened since then.
They're looking at how the composition of the soil on the moon changes and the elements that are still in that sample today.
What it does is it gives us a way to look into the interior of the moon without actually going there.
From UT, the samples will go to the University of Massachusetts and then to the Argonne National Lab in Chicago. Researchers plan to work closely together to make sure the samples stay as untouched as possible before moving on to the next team.
It is amazing that these rocks were collected so long ago, and we can still wring brand new, unheard of data out of them. And hopefully, this also is a good way to remind everyone that we can move on, that we can go back to the moon.
And this time, the moon is a stepping stone.
The SLS rocket it's an opportunity for us to send humans back to the moon. It is our goal to send the first woman and another man to the moon by 2024. And I get to be a part of that. We call it a dry base structure.
Patrick Hull is an Oak Ridge native and structural engineer at NASA's Marshall Space Flight Center.
This could be the highlight of my entire career at NASA, is being a part of something this big.
Right now, he's working on the SLS rocket. NASA says it will be the most powerful one in the world.
Humans will have the opportunity to go deeper into space than ever before on this rocket.
The program is underway now. NASA says it hopes to launch the first of 3 flights next year. The first flight is a test. The second will have astronauts on board and will get close to the moon. The third flight in 2024 will land astronauts on the moon once again.
Well, in the same flavor as Kennedy challenged NASA to put boots on the moon by the end of the 1960s, Vice President Pence has challenged us to do that by 2024.
America will lead mankind to the stars once again.
We are accepting that challenge, and it is tough, and we are going to work very hard to get there.
After the moon, the next goal is a mission to Mars. Technology designed at Y-12 National Security Complex could make that possible.
When you go to certain parts of the solar system, I mean the dark side of the moon, you start going to Mars, you don't have solar in those areas, so you have to have another power source.
That power source is Krusty, a nickname for the kilopower reactor using Stirling technology. Researchers in Oak Ridge say it opens up a whole new level of space exploration.
There are missions that, especially outer solar system missions, that are absolutely not possible without a Krusty type technology. It could provide the amount of power to basically run the systems that are needed at a space colony.
Now, NASA uses solar power for just about everything in space, but that's not an option for deep space missions like Mars. Krusty is essentially a small nuclear reactor, which makes its own power using enriched uranium.
It's just a very harsh environment. You don't have the electricity that you have. You don't have the water that you have. And so these type breakthroughs of coming up with ways to have the electricity, because if you can have the electricity, then you can also create water, and you can have all of those essentials you'll need for space exploration, colonization, those type things.
Y-12 says the project was a challenge. It had a tight deadline and a small budget.
If we failed in this demonstration, and on our part, it could scrap the entire that portion of the space reactor program.
Now, as NASA looks to the future, it continues to draw on its past, returning to the expertise in East Tennessee to help carry humans back to the place responsible for one of the most celebrated moments in recent history.
32 minutes past the hour. Liftoff on Apollo 11.
We knew that we were going to land on the moon, and as kids, you know, we would stare up and get out on the street at night and play underneath the street lights and look up at the moon and said, you know, man's going to land on the moon.
Tranquility Base here. The Eagle has landed.
These are things that just decades before people thought of as science fiction.
You know, it was just a thrilling thing to be a part of.
I still think about it.
That's one small step for man.
Holy cow, you know, we're on the moon.
One giant leap for mankind.
We were all one group enjoying this historic moment.
Be a part of the most powerful rocket in the world, and I'm putting my fingerprints on it. This job is really a dream come true.
And Apollo started it all.